Okay. Hello everybody, welcome to this last slot before the closing keynote. Thanks for being there. I'm Sébastien Deleuze. I'm working as a Spring Framework core committer at Broadcom in the Tanzu division. And as you may know, I'm a big fan of Kotlin, and we are going to talk about the next level Kotlin support in Spring Boot 4 that is coming, and related new features. So thanks for being there. I work on introducing the Kotlin support initially in Spring Framework 5 in 2017, 8 years ago. So quite a long time. We introduced the initial null-safety support, various extension functions, DSLs, etc. And since we have been continuing to refine that with better coroutine support, and I think there is really big companies that are using Spring plus Kotlin. Not everybody is public about that, so I try these days to find some people, and if you are in big companies using Kotlin, please reach to me, and we can basically be a bit of communication about that, because there is very big companies, very big project working on Spring plus Kotlin, and I think we should communicate a bit more on that. But yeah, the support is pretty cool. But today we are announcing a new major step, because we are starting a strategic partnership between JetBrains and Spring to mainly turn the current organic collaboration that we had for 8 years into a more involved collaboration, a more strategic collaboration with investment on both sides. And this is in this quote what Jürgen and me are saying. We want to make the Kotlin developer experience with Spring even better, and we are going to invest on both sides with some strategic move. So the next major version of Spring Boot 4 is going to be released in November this year. So most of the new features we are working on will be delivered via this new version, which will be based on Spring Framework 7. It is going to use a baseline of Kotlin 2.2. That means that the minimal version to use Spring Boot 4 will be Kotlin 2.2, and we will support, of course, upcoming version. You can already use Kotlin 2 with Spring Boot 3, but you need to customize potentially the dependency management. It's not very well tested on our side, so totally possible, no problem. But Spring Boot 4 will be the first version to really use Kotlin 2.2 as a baseline, and that will notably improve the compilation speed. So the Kotlin team has done a huge amount of effort on compilation speed. There is also the native IntelliJ IDE support based on Kotlin 2, so even the IDE experience will be faster, and just is going to unlock a lot of evolution in the language, and we are going to see a few of them in this presentation. So we have introduced quite a long time ago the null-safety of Spring API, but we are going to reach a new level. I have presented this morning the JSpecify support, which will be improving the Kotlin null-safety that we have with the Spring APIs. A few months ago, I merged this huge commit that basically turned and migrated the existing GSR 305 Spring null-safety annotation to JSpecify. So basically, we changed all the annotation in all the code base that add null-safety on generic types, varargs, and array elements, for example. And now we are checking consistently all the null-safety with technical issue. Okay, back. We are checking all the null-safety with the null-away plugin. That means that for every build of the Spring framework, we are checking that the null-safety consistency is fine. And I think that's going to improve a lot the developer experience on Kotlin plus Spring. So you may be aware, but the way it works, we are annotating Spring Framework packages with @null-marked, which says basically the default is nothing is null, and you need to explicitly specify what is nullable. So every package of Spring Framework is annotated with this null-marked annotation. And then in the various APIs implementation, we are annotating the type usages that need to be nullable with @nullable from JSpecify. And it is natively understood by the Kotlin compiler as of Kotlin 2.1. So basically, if you are using Kotlin 2.1 or next, there is nothing to configure. It will be understood automatically. So if we were using Kotlin without JSpecify, we would have what we call platform types. This is this exclamation marks that say basically the return value or the parameter, the null safety is unknown, so there is no check for null safety. with the version that you have at the right with the exclamation mark, everything is basically null safe, and so it looks like a Kotlin idiomatic API. And like I said, there is no additional configuration required. So previously, with the current generation of null-safety, you had to configure your project with -JSR 305 equals strict in order to trigger some compilation errors when there was some null-safety mismatch. With JSpecify, it's natively an error. You have nothing to configure. The Kotlin compiler natively understands what happens. And the biggest new feature is that this null safety is portfolio-wide. So it's not just about Spring Framework and Spring Data, like in the current generation. All the project, all my colleagues from the Spring team are currently working pretty hard to introduce JSpecify notation, check them with null-away plugin. So it's quite a lot of work, portfolio-wide. We are talking about Spring Boot, Spring Framework, Spring Data, Spring Security, Spring AI, etc. Our goal in November is to reach the maximum of support, and hopefully close to every public API will be covered. So all usage of Spring API from Kotlin will, in theory, use full null-safe API. It will look like much more idiomatic than what we have currently. If you have tried Spring AI 1.0, we have not yet introduced the annotation, so yeah, you may have to do some exclamation mark to deal with that. The second big feature is the new bin registration DSL. So it's pretty close to what you know in terms of syntax, but the foundations are much more stronger. So it's basically a foundation for better programmatic bin definition. The new support that we introduce is going to supersede the bin definition DSL and the bins DSL that you may already know, and it will improve the integration in Spring Boot and allow more usage. So basically, the bin registrar DSL that you are going to use with Kotlin extends a new contract, which is bin registrar. I'm going to show you the contract a bit after, while the previous bin definition DSL was extending a much more low-level contract, which is application context initializer. It allows to build custom configuration DSL. Unlike the current support, there is full support for Spring AOT optimization. Currently, if you were using this existing bin DSL and you were providing some bins with some lambda, it was not supported. So Spring AOT generation was failing, it was impossible, and so a lot of people were using that with Spring AOT for optimization, and basically it was not working. So now it's working properly. We have also seamless integration with Spring Boot and add configuration world, so you are going to see that change a lot of things. And it's usable by libraries via automatic discovery, because any add configuration class can use this kind of thing. So the Java contract is the following. You have a bin registrar API that is natively, it's a core concept that is understood by Spring. You have bin registry and environment. And if you are using it from Java, of course, that's more verbose than Kotlin. So you can use this API to, it's basically the Java version of the DSL that was previously only provided on Kotlin side. Now, in order to provide first-class support in the framework, we need to provide the equivalent for Java developers. And of course, Kotlin developer will use a much better version. But the goal is basically to use lambdas and more functional construct in order to declare your bins. By the way, even if the Java version is more verbose, it can be used and hopefully will be used by some Spring project and even your project to create some custom DSLs. So basically, by extending this bin registrar via a potential security registrar, by the way, Spring Security does not use yet this mechanism, but it could be the case later. You can provide an abstract class security registrar that is going to expose some custom register method, and it will basically override the original one with bin registry and environment. And that means that on user side, you can provide a pretty nice DSL that is allowed to cover some, basically some domain like security, but maybe also the configuration of your expertise, your model, basically specific to your company. So even for Java developers, that should allow to write some DSL that can register multiple bins, do if statement, for loops, etc. So it's a pretty powerful mechanism that can do much more things than add bin, where basically you have one method that is going to generate one bin. Here, that's much more powerful. So even for Java developers, that will be useful. On Kotlin side, we have this bin registrar DSL, which is basically going to extend bin registrar but provide a much more Kotlin-ish API. The API itself is pretty close to what we have currently, but it's more well tested and it will provide more capability. But the syntax is pretty much the same as what we have currently, and this is the most efficient way to register beans. What really changed is how it is integrated into Spring Boot application. Previously, again, we were basically using a kind of low-level application context initializer contract. It was not really a good fit with Spring Boot and libraries, etc. So now you can just use @import with the beans class that we have seen just before. Okay, you write your DSL, it's a class. You are going to use @import with this class, and this will be automatically understood by Spring Boot. By the way, we are not using the @Spring Boot application annotation, which imply class path scanning and making application a configuration class. Here we are just using enable auto configuration, which is typically what we want. We just want to have the beans with, for example, some REST client builder, some default beans that Spring Boot is going to create, and we are going to provide our custom ones with that. And of course, you can, and this is very powerful, you can provide that in any, you can annotate with @import any configuration class in your library, in your application. That means you can totally build some Spring library, annotate that with @import, and that will be discovered automatically by any Spring Boot application using it. So the integration with Spring Boot, with the test, with Spring IoT, etc., is much better. And hopefully later we will leverage that more in Spring Boot and Spring Security, etc. So it's not just a tool for Kotlin developers, but it will allow better integration of the basically the DSL for registering bean in the Spring ecosystem. We are going also to introduce, mostly the Kotlin team is going to introduce a more efficient Kotlin reflection implementation. The current version of Kotlin Reflect, the dependency that we are using to do some reflection on the Kotlin code, it's in fact based on a subset of the code of Kotlin 1 compiler. This is pretty slow. I mean, a compiler is not designed to be run at runtime, and so there is basically a pretty important impact. In the measure that we did, we see that basically using Kotlin plus Kotlin Reflect versus the same application in Java on a small application, it increased the startup time by 15% and the memory consumption by 20%. Of course, in a bigger application, the impact will be less, but here this is just a simple application. We did an experiment with basically the Kotlin JVM metadata basis that will be, it's a new library that is supported by JetBrains. And we use this experiment to see how fast Kotlin plus Spring Boot will start without Kotlin Reflect and using a more lightweight, future-proof version. And you see that basically the startup time in now, the overhead for the startup time is just 2%, and the overhead for the memory consumption is almost nothing. So it's pretty promising, and we agreed with the Kotlin team to work mainly on their side. Alexander Udalov, which is one of the most senior developers in the Kotlin team, is working on keeping the API of Kotlin Reflect, but it's going to re-implement everything using Kotlin metadata JVM, which is already first class based on Kotlin 2 infrastructure, widely used in the Android ecosystem, and basically is going to remove all the Kotlin 1 implementation, Kotlin 1 compiler implementation, and use this new library to hopefully keep the same API, so no change for the ecosystem, for Spring, for Jackson support, but much better performances and basically no overhead compared to Java. So I think that's pretty cool too, if they achieve to do that in a non-breaking way. This will not be available for Spring Boot 4 because we have a Kotlin 2.2 baseline and it's not part of Kotlin 2.2, but you can expect that to be available in, not sure, Kotlin 2.3, 2.4, 2.5, and in a subsequent Spring Boot 4.x version. But again, it should not be a breaking change. The other thing that we would like to improve is the inline value classes support. Due to some various technical constraints and the API that Kotlin Reflect is exposing, Spring has to box parameter and unbox return value, creating an overhead around the inline value classes usage, which is expected to be super efficient. So that's a bit frustrating. We are using inline value classes in Kotlin to go faster, and Spring has to do some stuff because the API exposed by Kotlin Reflect is not well suited for Java framework. So I have created this issue, and I would like to work in collaboration with the Kotlin team in order to remove this overhead and get just better performance with Kotlin inline value classes than with regular Java records, for example. So I think that will be the second step of the optimization that we will do. Again, no breaking change for you. It's basically a collaboration between Kotlin and Spring teams. Now we are going to talk about CDS and AOT Cache, because I like working on runtime efficiency, and I think that's not specific to Kotlin, but that's cool to see that we can leverage that with Kotlin as well. So it's about basically doing a training run of your application, generate a cache in order to start your application faster, consume less memory, and even improve the warm-up capabilities of your application to reach peak performance faster. I think you had some mention of that in the keynote yesterday. And so CDS, with this class data sharing, which is a pretty old technology, is now supported by default with Spring Boot and Buildpack. So basically, just by enabling a flag, you can automatically do the training run, ship the cache within your container image, and you can basically start your application faster. If you are using Dockerfile, it's also documented in the Spring Boot documentation, so please check. There is a successor for CDS, which is called AOT Cache. So AOT Cache, it's a new feature that is introduced in Java 24, so recently released. And this is introduced by this JEP 483, ahead of time class loading and linking, and it's basically a better CDS, okay? So start faster, basically, around 10–20% faster. But AOT Cache in Java 24, this is just the beginning of the story. AOT Cache is going to mature in Java 25, 26, 27. So if you begin to use AOT Cache today or tomorrow, maybe with Java 25, the next LTS, it's a good bet into the future because the Java platform is going to work on that and you are going to have additional benefits. So speaking about additional benefits, here this is a startup time of Pet Clinic compared to the executable jar. If you just unpack with the feature that we ship as of Spring Boot 3.2, I think, 3.3, you can start a bit faster. If you are using CDS or AOT Cache, you start your application around 2x faster, 2 times faster. So this is available in Java 24 in production supported version. And if you are using the upcoming support for AOT Cache with code compilation, which is coming later, I don't have any timeline, you can speed up the startup time by 4x. And unlike GraalVM support, there is less side effects, no metadata ins to provide, it's a regular JVM, so the benefits are less involved than GraalVM, but there is less side effect. It's actionable even on legacy projects, and it works pretty well in legacy project with a lot of dependencies. So the goal is to provide something that is actionable for the majority of projects, and I think that's pretty exciting. Memory consumption, we shave around 20% of memory consumption around that. And this is the most interesting thing, I think. As of Java 25, there is going to be improvement of the warm-up. So here, the principle is that you are going to get some profiling data from your production or from a staging instance where you are applying some workloads. The goal is to have some realistic workload applied to your JVM in order to get a hot JVM with something that is corresponding to your production workload. Here, I have a blue line, which is basically the throughput, requests per second, when I apply the workload on some Pet Clinic endpoint. Okay, this is the baseline, regular JIT, and it takes around 30 seconds to get your JVM warm and providing the best performance. If you are using AOT profiling, which is going to be available in Java 25, at least the JEP target Java 25, so we are talking about just a few months, September, I think, you are going to have a faster warm-up. And if you are using AOT profiling and code compilation, so here we are directly taking the native code that the JIT compiler has compiled in production, you can have an even faster warm-up. And so the red line, you will be able to achieve it with Java 25. The yellow line, it will be a bit later. You can see there is a difference in terms of peak performance plateau. You can see that the red and the yellow line are lower. This is just a temporary limitation that is expected to be fixed by the Java platform team. So you can expect the same peak performance when everything is hot. But yeah, it allows to make a regular JVM without native, warming up pretty fast. So combined with the 4x startup time, we can maybe think about, yeah, maybe scaling from 0, at least scaling from 1 to an instance much faster, and being able to absorb more workloads and spend less CPU cycle to warm up your JIT. So I think that will basically make your CPU consumption and memory consumption more predictable on production. And this is available for both Java and Kotlin, so let's take advantage of it. Next, Spring AI Kotlin support. So we have released Spring AI 1.0 very recently, like a few days ago, and we have added some Kotlin support. There is not yet null-safety annotation, so that will come. We are going to work on that. But there is some Kotlin support already. So for example, we have this structure output feature that is basically going to adapt basically what OpenAI returns to a class. Here, this is math reasoning. And it's going to generate a JSON schema based on your class and map the result, map the response to your class. And in order to use that with Java, you have to do those terrible things. So you have to provide the JSON property required equals true for any mandatory property, because you need to provide exactly the JSON schema that is required, and that's quite verbose. So in Kotlin, thanks to the contribution from the Kotlin team, we can just leverage the null-safety information to know if a property is mandatory or not. So the code is more concise and more nice. With Kotlin 1.x, you still have to use this use site annotation specification. So you need to write add get JSON property in order to, in the generated bytecode, to get the annotation on the right place to make Jackson, or it's the same with Hibernate validator, etc. There is a lot of Java-based framework where basically they are not able to see where Kotlin put the annotation, because this is just on the constructor parameters. This is not on the field or something like that. The good news is that the Kotlin team has been working on fixing that. So they are changing how Kotlin works, currently with a special flag in Kotlin 2.2. So you have to write -x annotation default target equals param property. But that will just make Kotlin compilation working like Java expects. So here, typically, it will annotate both the final answer constructor parameter and also the baking field. And so Jackson, Hibernate validator, all the regular typical Java libraries, they will just understand regularly the regular Kotlin annotation, and newcomers will stop complaining that basically my annotation is invisible, what's going on, and even myself, I mean, I usually do the mistake. Just regular annotation, it works with the whole Java ecosystem. This is a small thing, but I think that's pretty cool to remove this noise and just use annotation, and it works. So pretty cool. I don't know when that will be enabled by default, but my hope is that at some point that will be just enabled by default without any flag. By the way, the Kotlin team has published already a tutorial for working with Spring AI and Kotlin. So if you go to the official Kotlin documentation, Kotlin website, there is a tutorial with Spring AI 1.0. So pretty cool. Yeah, and so this is new features, but I wanted to share a new reference application because I think it's important to explore more Kotlinish way to build Spring application. If you are using Kotlin plus Spring in a traditional way, like you are using GPA, Teamleaf, FreeMarker, whatever, I mean, it's perfectly okay. And this is the superpower of Spring plus Kotlin. You can write that like you just change the language and you keep the same technology, the same libraries. It's perfectly fine, it's not bad, it's super cool. And Spring plus Kotlin has some adoption also for that. But I think it's important that Kotlin provide more added value than just being a better language, because Java has evolved. Java is pretty good these days, and it's not enough, I think, to increase the adoption of Spring plus Kotlin to just be a better language. We need to provide better added value and think about some more Kotlin-ish ways to build Spring application. So I have been working just in a few hours, couple of days, so need to polish it, but Spring Pet Clinic with a K instead of a C. So this is a more Kotlin-ish way to develop Spring Pet Clinic, it will look like the same because I'm not a website designer, but the implementation will be very different, and we are going to explore that today. It's available on my GitHub, so feel free to have a look. Feel free to submit pull requests. I need to improve a few things, but I'm here to share some ideas, and we will iterate. So the goal is that we are going to have a backend module, which is basically implemented with Spring Boot 4 snapshots. So we are going to see a new features. It's using a Postgres database, and it's going to use some shared code between front-end and backend. In this application, I'm using primarily some server-side generation, so I'm not here to create a rich internet application that is not usable in concrete website. I'm still generating the template mostly on server-side, but like usual, you still need to have a bit of dynamicity on the front end, and for that I'm using Kotlin WASM. That's a bit overkill, but that's cool. And we are sharing, so we are not using JavaScript, not a single line of JavaScript has been written in this project. And we are sharing the template rendering, the validation of your business model, and the DTOs between front-end and back-end. We have also an open Spring AI-based microservice that is compiled with BuildPack and GraalVM. And it is going to generate some fancy pet image, pet photos based on some prompts. So yeah, let's see how that goes. So we are going to see first a demo of that application. It looks like a regular pet clinic, but you will see the implementation is very different. So we have 4 modules, front-end, back-end, shared, and AI. Okay. I'm going to check the Docker Compose. I have already built everything before. So we have a Postgres database. We have a pet clinic, which is based on Spring Boot 4. And we have an AI module, which is based on Spring Boot 3.5 and Spring AI 1.0, because Spring AI is not yet compatible with Spring Boot 4 snapshots. And that allows me to show you GraalVM, etc. So I'm basically starting my application on my local laptop. And you see it starts pretty fast. So the pet clinic module is using CDS and starts in 700 milliseconds. And my AI module is using GraalVM and is starting in 50 milliseconds, so pretty fast. Our application is really look like regular pet clinic, nothing super fancy. So we can list the veterinarians. We can find owners. This find owner is using some client-side rendering. So for this part, I'm doing some client-side rendering because that matters. We can view the owners. We can edit it. We have some client-side validation of everything. So if something is wrong, again, I'm not a designer, so just JavaScript help box. The key point is that the business rules are shared between front-end and back-end. Okay, so I'm going to use exactly the same function to validate on both sides to ensure consistency. I can basically modify that, okay, and I can add a new pet. Here, I'm going to use a new feature that is using the Spring AI integration to basically specify a prompt to generate a new pet image. And so here, I'm going to generate a dog with the prompt, a mysterious dog eating pasta. And so we are going to see what DALL-E from OpenAI is going to generate. Obviously, that takes a bit of time because AI stuff needs to happen, so it's going to consume a bit of electricity, etc. And we are going to see that, in theory, a mysterious dog eating pasta is going to be generated, and this is the first major feature in Pet Clinic in years. Okay, can we check? Is it a mysterious dog eating pasta? Yes, I think it's, and I have a better one I will show you at the end. The best one, the one I had the first time. Okay, that's cool. We are going to see, because honestly, the demo is not super impressive, that's just regular Pet Clinic. Maybe we can do better, and I can collaborate with you on a nicer front end, but the goal is to have a technical demonstration of Spring Boot 4 shared code with Kotlin multi-platform between front end and back end. So we have our project, so the backend project. It's using Gradle Kotlin DSL. It's using snapshot version of Spring Framework 7 and Spring Boot 4. I'm declaring, for example, Kotlin serialization JSON for the serialization instead of Jackson. I'm using Java 24 because I enable by default virtual threads, By the way, virtual thread with Java 24 is solving the thread pinning issue that was limiting the scalability, so I advise you to use Java 24, 25 when available, and enable virtual thread with this flag. Super, I think it's production ready with Java 24 before, not really. We have a bunch of Spring Boot starters, Spring Starter Web, Spring Data JDBC, the cache support, and a bunch of Kotlin dependencies like the Kotlin HTML that we are going to use for the template rendering, Kotlin serialization, Conform, it's a validation library that we are using on both backend and frontend. We are doing a bit of configuration to copy what Kotlin WASM is going to generate on the front end and to copy it into the static directory. So Spring Boot is going to serve the JS and WASM file that Kotlin WASM is going to generate. And we enable the efficiency features like CDS and Spring IoT with these two flags. And so when we build the container image with buildpack, it's going to generate the cache and use it by default, etc. Okay, let's now check our application. So we are using the new bin registration DSL, of course. We are just using @enable auto configuration, no class path scanning. We are enabling the caching. And we are going to import our bins via this @import bins class. So yeah, so you can mix basically both functional and annotation-based programming model. It works pretty well. If we have a look to our bins class, we are going to use the new DSL to declare various bins. So here you can see that we are getting some property from the environment. In order to, we are reusing that to create a REST client instance with this register bin syntax where we provide a lambda. We are also providing a custom HTTP message converters instance in order to disable the default converters and just use the string and the Kotlin serialization JSON1 because we want to have basically the minimum of overhead. And I'm using basically this syntax to invoke some callable references to various web routers, which is using the regular web routing API that we are providing for quite a long time now. So here, I'm basically, for slash, I'm generating some content with Kotlin HTML. So Kotlin HTML is a kind of Kotlin DSL that allows you to generate some code. There is full autocomplete, etc. So everything is type safe. And it's basically just a function that you are going to customize. So here, I'm creating the layout. You can see the Kotlin DSL look like a bit like HTML elements. Everything can be dynamic, of course, and it is on the shared module. So this template can be rendered both for front-end or back-end, like I want. We have other routers where we are injecting repositories. So here the repositories are going to be injected by type automatically. Here I'm going to use Spring Data JDBC for the implementation, no Spring Data GPA because that does not allow to provide idiomatic Kotlin code. I can either do the rendering of my template that is defined here or just return JSON using Kotlin serialization JSON and that will work as we expect. We have an owner router here that is going to get the parameters from a form submission in our post request, do some validation. So here you can see that we have our DTO that is annotated with @serializable to be used with Kotlin serialization JSON. Again, we are in the shared module. We are writing the validation logic not using annotation, but using conform, which is a kind of DSL, to define your validation rules. And we are still in the shared module, so we can share this validation logic from front-end or use it from the back-end. And we can write common tests. So here, I'm writing some tests that are not running specifically or JVM or WebAssembly. You can execute them on both. And I can run, so here I'm running the test on JVM side, but I could run them on WASM side as well. And that's going to check that my validation rules are working as expected. I can also write tests to check that my template rendering is working as expected. And there is nothing specific to front-end, back-end. This is just shared code. And that's it. So here I'm providing some fake data, rendering the template, checking that the generated string contain what I expect, and that's it. Okay, we are now going to see the image generator with Spring AI. So basically, the Spring AI stuff is based on Spring Boot 3.5, which has been released, I think, today or yesterday. We are going to use Java 24 as well because we want to use virtual thread everywhere. So we are going to use it there because more scalability, less consumption of memory. We are defining the Spring AI 1.0.0 BOM in order to get the default version, and we are going to use our Spring AI starter model OpenAI because we are going to use DALL-E in order to generate some new fancy photos. So here we have a very, very simple application that is just providing an application class and is using some properties, like we are providing the OpenAPI key from the environment variable, the size of the image that we are going to generate, and a single controller that is just using basically the capabilities provided by Spring AI. We provide the prompt in the path variable, we call DALL-E, and we return the URL of the generated image, and that's it. Very simple. Just take a bit of time. Okay, and you can generate some very nice picture, like this one was the first one I generate, and I really love it. It's super weird, but yeah, not sure. Very artistic. I was not able to generate another one in my demo, so I wanted to share this beauty with you. It's crazy. We are now going to see the front end with Kotlin WASM. So, of course, I could use Kotlin JS, but I mean, Kotlin WASM is faster. I think it's a better bet for the future, and that allows to provide some pretty small output, and I think that just makes sense. So, here, the goal is to not pay the price to learn the whole JavaScript ecosystem just for a bit of validation logic. My goal is not to do everything on the front end, it's just to implement the dynamic part of the front end with Kotlin WASM. So I'm using Kotlin multi-platform. I'm declaring that I'm working with the WASM.js target, which is using WASM.gc, which is supported by all major browsers, including on the mobile. And I'm going to use a bunch of Kotlin multi-platform libraries that are also usable on the front end. So I'm using Kotlin serialization JSON for the serialization, deserialization with JSON, Kotlin X browser to provide access to the DOM APIs, and conform for the validation. And so I have just implemented just a small part of the logic with that. And so with the search owner form, you will see that basically with Kotlin browser API, we are getting the value of the last name that we have in the input. We are generating an URL, and we are basically using a window.fetch. So we are exposing in Kotlin some browser API, getting the results, and basically deserialize that to some list of owners that we are going to render using our shared logic. And basically, we are going to inject the result within an element in the inner HTML thing, and that's it. So this thing is basically front-end rendering, client-side rendering. For some other parts, like edit owner form, I'm just getting the form data. I'm just doing the validation of the owner. This is the alert box that you saw in my demo. And basically, this is also the validation logic that is used on server side in Spring Boot to implement the very same validation logic. And so it's a way to duplicate code. And honestly, it works pretty well, even if my implementation is a bit raw. And I have a call for action because Kotlin HTML for the template rendering, it's a bit, I mean, it's existing for a long time. It's pretty mature, but I think we can do better. There is a library which is called Compose in the Kotlin ecosystem, and there is various variants. There is Compose for web. You can use Compose on the desktop. You can use Compose for Android application, etc. And the philosophy of what is implemented right now is just pixel perfect rendering on every platform. So Compose for web is basically shipping 4 or 5 megabytes of WebAssembly in order to draw everything pixel perfect. So you are shipping a whole rendering engine on the front end. Maybe for backend it's cool, but myself, I want to write public website. I want to write accessible website with the DOM, etc. And of course, with WASM, I can maybe include some fancy component developed with Rust that will be rendered super fast. There is a lot of things that we can do with Kotlin WASM, much more impressive than what I have showed here. But I think that we can do something that is useful for developing regular website, like it could be the Vue.js or the Angular of Kotlin for the front end. And there is such thing that already exists. It's named Compose HTML. So Compose HTML is using the Compose very nice programming model. but it applies it to basically HTML elements. So you can create some buttons, some text area. You are basically defining some logic, and honestly, the developer experience is pretty cool. But right now, it's only support Kotlin.js, so my ask to the Kotlin team would be, please add Kotlin WASM support. It's only useful primarily for client-side rendering, so what I propose is that the initial rendering will be done on server side, and then it will be iterated on client side. By the way, there is a framework called Cobweb in Kotlin that is doing that, but it's battery included, and it's not really usable with Spring. Do some footprint optimization to get a very tiny footprint, like a very small WASM file on the front end, and some auto-loading, because if you are checking the demos of Compose that have been shared yesterday at KotlinConf, I was at KotlinConf yesterday to present this talk, the hot demo reloading are amazing. I think with a bit of coordination between Spring team and the Kotlin team, if they work seriously on Compose HTML, because right now it's not really front and center, there is some Compose HTML support in the repository of Compose, but there is no really first-class support. So yeah, I think we can do better than this Kotlin HTML thing, and I think Kotlin via Compose already provides this nice developer experience. We just miss something that can, instead of shipping 4 megabytes of WASM and doing pixel-perfect rendering, duplicating all the rendering pipeline of the browser, we can just do that like the JavaScript framework, but with a Kotlin developer experience, and combined with Spring Boot on server side, I think both together could be super powerful. And I think this is the kind of thing that could increase the adoption of Kotlin significantly. So yeah, we are coming close to the end. Spring Boot 4 will be released in November, so feel free to test it. It will contain the first-class null-safety, the new Registrar DSL. There is much more Kotlin features that are coming. The more efficient Kotlin Reflect will not be available yet because it requires some time, but I think it will be available next year. And yeah, thank you.